So welcome to, I think, is it the fourth segment of Lightning Talks? I hope you're not tired of them already. Thank you. That energy, I love it at 8:30 in the morning. Can I please borrow some of that? Real quick, if you're here, Carlos de la Guardia, Alex Rodriguez, Brian Warner, Yuri checked in, Michelle Fullwood, Thomas Ballinger, just come up to the front and just say hi. All right, so the first up, who stole my meme, apparently, from my Friday talk, is John Jarvis talking about Raspberry Pi.
Hello, test, test. Hi, my name is John, and I'm going to give a quick talk here on a hack, a very easy hack with the Raspberry Pi. So as everyone, or most people know, we were given free Raspberry Pis last year for PyCon, and when I got mine, I wasn't really sure what to do. I had a lot of ideas. So one problem that I was seeking out to solve was very early when I was working at my current job. People were passing around credentials using thumb drives, and it was a problem because from a security perspective, you don't like it when people in general are using them for sensitive data. Also, there's documents and things that they were passing around, and there were a lot of thumb drives just lying around. I wasn't really sure if there were sensitive, if there were any important sensitive data on them. So as a sysadmin at the company, a transformation began. I started out as this quiet, solitary sysadmin person, and then I became the judge, jury, and executioner of all things thumb drive. So this hack is called the Stick Destroyer. What it does is that you put a USB thumb drive in the Raspberry Pi, and there's a little LED that you attach to it. It takes a while, but what it does is it slowly formats the drive, writing over every single sector, and then the LED goes on, and then you take out the thumb drive, and it's reformatted, and it's pretty secure. And there's some caveats here. So with thumb drives in general, there's really no secure way to completely destroy them without actually taking a hammer to it. There's technical reasons for that, but in general, this is not a super secure way, but it's a reasonably secure way to erase them. So if you want to do this hack, all you need is a Raspberry Pi, an LED, a resistor for the LED. I have the code up on GitHub. It's a Python script that essentially just runs shred over any block device that you plug into it. That's it. Thank you.
Thank you, John. Up next, we have Yaroslav Galchenko speaking to us about fail to ban.
And because I need to start with promotional materials for my company, and I'm not sure if I could say on behalf of Dartmouth College, but in Debian project, we are hiring for the last 20 years, and pretty much nobody was fired. People only retire, so we welcome more of workforce. But today, we will not talk about Debian or NeuroDebian or PyMVP. We'll talk about fail to ban. And I wanted to check actually with you who doesn't know about fail to ban. Please raise your hands. Does not know, right? Wow. Okay, so I was right with my estimates from PopCon popularity contest of Debian. This is how many people installed fail to ban, and if we look at the proportion of the people among all the submitters for popularity contest, it's about 8%, and we are kind of now in the stable point. So I hope that after this meeting, we'll get a little bit of raise in this chart too. So what does it do really? Probably you run some servers, and most probably you run at least SSH server, and sometimes you want to procrastinate and look how it's been bombarded from outside. And you just either ban that IP manually by adjusting your IP tables, or you go sleep safely because your users did it all secure way and notion of heartbeat didn't exist at that time. And then somewhere in the middle of the night, those guys succeed and finally get access to your box. So what should you do? If you're running Debian system, as many of you do, I believe, so you just apt-get install fail to ban, and I recommend also to install logwatch, and that as a result of that, you will get just few attempts to connect. Then this IP will be banned for 10 minutes and automatically unbanned later on, because it could have been you who have been banned, right? And those cases exist. And then next day, LogWatch email will deliver you a message that, oh, there were so many IPs for this specific target banned, and you know that your box is experiencing this whole glorious attacks. So how does it know about that? There is few configuration files. One of them is filters, which define all those regular expressions, which work on the log files and figure out that they're under attack. And there is a host tag which grab IPs from there, and of course, based on the date, it bans IP and then unbans it specific time after. And then action, right? That's what will happen, what banning consists of. In this case, we set up some chains in IP tables. Then whenever attack happens, action ban is called. So we block type usually reject or just what is it? What is the second one? I forgot. So you reject that package or just drop it, right? And as a result, usually attacks stop quite rapidly. And the third file is a jail file, which brings those together. So you specify the filter and which actions should be taken upon that filter being triggered, right? In this case, it will be IP tables and also send mail. So it will send me information about the IP which triggered that filter. And I specify that it should try at most 3 times to log in. And will ban for 600 seconds, which is 10 minutes. So how does it know any better than SSH? It knows quite a few filters. So if you run Apache NGINX or mail server, we have configurations for many of those. And as for actions, it can be ran also on OS X or any other distribution of Linux. I'm not sure about Windows, unfortunately, guys, so I'm sorry. And recently we released 0.9.0 release for those who run fail to ban, which might be somewhat exciting. We have multi-line support now and timeout option for action. So if your action actually stalls, before it was kind of disaster because then the whole pipeline stalls, but this one fixed it. Not yet IPv6, but we are getting there. And so help yourself, install it. Don't modify the files which we ship, configuration files. Of course you can, but then with upgrades it becomes difficult for you. So use either .local or directory with all additional configuration options. And report bugs in your distribution, or just contact us on the mail list or IRC. I would beg you not just to blog, but contribute back. We sometimes run into blog posts like, oh, I've discovered fail to ban and I've created this beautiful filter, and then we look at it. Well, yeah, it's good that it works, but it might break quite badly on you and cause some denial of service attack, because you need to be quite careful how you construct those regular expressions to prevent any injection. Or go to our wiki, contribute there, or of course, clone the code on GitHub and provide us with fixes or tests. There is still room for improvement, and we have developed file which will guide you. And of course, spread the word. Apparently not everybody knows about it, although quite a few people use it. So thank you, and thanks everybody who contributed to the project.
Thank you. Thank you very much. Alex, if you want to come set up here. And then on deck is Brian Warner. Awesome. So I have a couple of things to say, just because I have the stage. Last night, at Pi Ladies Auction, we raised over $12,000. So it's 20% more than last year. Yep, pretty awesome. And like over $3,000 from T-shirt sales. So we have like 15,000 from just PyCon. So that's pretty great. All going towards financial aid next year. And speaking of financial aid, if you are a financial aid recipient and you have not received your funds, and if you selected like a check or cash or PayPal but can accept a check, or you don't know what disbursement method that you selected, please go to room 514C, which is over there at around 10 a.m. today. All right, so next up we have Carlos de la Guardia talking about Substance D.
Hi, everyone. I want to talk to you about Substance D, which is a web application development platform, an application server, whatever it's called these days. It's based on Pyramid. I mean, the framework, not the T-shirt. It takes advantage of Pyramid's unique extensibility and pluggability features. The developers define content, they're using Python, normal, and they create applications using views that are registered to one or more of the content types they created. The content is stored in a tree, like a file system in an object database. Substance-D provides out-of-the-box management interface so that you can extend it by adding custom forms or other views or any management features that you can think of. Its more unique features are it allows undoing actions taken via the management interface. You can undo any action invoked against the database programmatically. Users can have undo buttons right after making a screw up and fixing it, taking it back. You can assign security declarations to any object or folder or whatever, so you can have row-level security. You can have security for this subject, only for this user, and only in this view, for example. It allows you to workflow content, so content can go from different states, like publish, draft, etc., whatever you can think of. And it also has an out-of-the-box search engine, which allows you to index content using field, keyword, and facet, or even full-text indexes. You can relate content objects to each other with referential integrity. You can evolve database content, I mean like South for Django migrations. You can migrate Python objects, think of it like that. You can dump the content to a text format that you can easily move to other places or import back into another Substance-D setup. And it has a nice audit log where you can keep track of any actions that the user does. Here's the Substance-D management interface. The front end of the application can look however you want to make it look. And this is the management interface. You can see the content here. And this is content that you defined using regular Python code. The code looks more or less like this. You can see there's the definition of the binder object, and then you can set some properties that, like which views are going to be shown. And you can add property sheets, which are pages of configuration that you can create. It's very easy to extend. Oh, sorry. And well, here's the content management interface. You can see that you can take a look at the database. You can do the migrations from this interface as well directly. You have security tab where you can make security declarations. And you can create your own permissions and define your own permissions. So you can come here and assign permissions for any group or users and have priorities for them. There are some services. Basically, you have user management and group management from here. You can create users easily here and assign them permissions. There's the undo tab. It allows you to take back any action that any user has created if you're an admin. If you are a non-privileged user, you only can see what you have done and change what you have done. It has an audit log where you can see any of the different things that users have been doing with some information about when and what they did. And well, here's the indexing information for any object. The interface is built for allowing easily to handle a large number of objects without any performance issues. So as you can see, this binder has hundreds of documents, and it's pretty easy to go. The user interface is also, it stays on all the time. So if someone changes something while you are looking at the folder and adds something, you will see it without having to reload. And well, you can create stuff pretty easily. And that's it. Let's take a look at it.
Thank you. So a SQL query walks into a bar. He walks over to two tables and says, "Can I join you?" So what's the object-oriented way to become wealthy? Inheritance. So we're really happy to have Alex Rodriguez here. He's a freshman at the University of Waterloo. Please put your hands together for him.
Hey, everybody. Like you said, I'm Alex Rodriguez. I go to U Waterloo, and I take mechatronics engineering, which means I'm cool like that guy. So what this talk today is going to be about is, for our final project, me and my partner and I decided that we were going to make a CNC. So this here's a CNC for those of you who only program and don't make much stuff. It cuts things automatically. That's the gist of it. Unfortunately, that kind's pretty expensive. So we stuck with Lego. But it was this is sort of what it looks like. So we finished our CNC. We're like, this is great. And then we're like, wait, how are we going to program this? So that's where Python sort of came in and started to give us some help. We looked at when you look online, there aren't really many options. You have Telnet, it's great. You got Visual Studio, C#. I wasn't like super excited to deal with any of these things. So then I took the great words of XKCD, and so I was reading along, and I was like, yeah, that'd be pretty great. What if I could just import NXT Python? And then I did, and it worked, and it was amazing. So I was just really, really thankful for everything that Python's done on that one. So we start off, it's about 8 p.m. We're like, this isn't working too great. It's like pretty ineffective because it has poor control. So we're just going to rewrite the control algorithm. Easy peasy, right? How hard could that be? So this is how it starts out. We start off, we write an algorithm to log the data and then pull it up onto my computer, and I use matplotlib to do graphs of the data. So if you have a look at this, you can see the green line is actually what's going on. The blue line is what we're commanding it to do, and the red line is the difference multiplied by 1,000. So you can sort of see it's okay. It's off by like 40 thou, which is not that great. So here's our first one. So we can do better than this. And sort of just to give you guys an idea of what's going on already is the current system is called PID, and it stands for Proportional Integral Derivative. And it's a way of controlling a position feedback system. So you have the proportional part. If we imagine that you're like a pilot and you're trying to land on a landing strip, the proportional part is you're like, oh, I'm way too high. I need to go down. And then as you're coming down, you realize that you're coming towards the thing very quickly, and you don't want to crash land into the ground. So you have derivative, which slows you down and you come up. And then we have integral, which allows you to sort of tune in that last little bit very slowly. So that's sort of the three elements of basic standard control loops. So we're like, this isn't very good. It's lagging quite a bit. So let's just crank up the proportional. So we did. And as you can see, the performance improves. However, we have this downside where it overshoots all the time. And it's just like, the more you crank it up, the more it starts to oscillate, it starts to perform really badly. So the problem is, fundamentally, that in order for this thing to be working really, really well and like following the line, it's going to have to, if we want it to get really, really close, then it doesn't know when things change. So if it's predicting ahead and it's estimating and it's arriving ahead of where it's supposed to be and it's arriving close to the line, then it doesn't really perform very well. So now it's 11, where we're starting to, got to get working harder. And so we came up with this idea, and we realized that it's really unreasonable to measure the exact command against where it is right now. So instead we forward shift 1, and you realize all we can expect from an algorithm is for it to get to where we told it to get to. So we compare where it is this tick against where it was told to get to last tick, instead of where it was told to get to this tick, because it didn't know that information. So we sort of improved that, and we slid it over, and that already improved things a lot, just to take a more realistic look at how things are performing. So now it's getting kind of later, and some more crazy ideas happen. So we're like, why do we need feedback control at all? We don't need that kind of stuff. So instead we set up this system which doesn't have feedback at all. It just tries to match the speed. And it's actually amazingly accurate, but it's not perfect. So now it's 3 a.m. We're starting to work pretty hard. And we sort of turn it all up. We add some position control. But again, we get these spikes, which are just terrible. And now it's really getting pretty late. And so what we do is we take the two and we mix together a proportional controller with a speed controller. And it gives us this amazing 6 thou, which is less than the resolution of our sensors. So we were pretty happy. So thank you very much. This has been an awesome experience, a really welcoming community. I want to say a special thank you to John Hunter for making Matplotlib. He sounds like an awesome person, and I'm very sorry I didn't get to meet him. Thank you.
Thank you, Alex. Alex kind of crept up on me, was it yesterday or 2 days ago when I was setting up the signups for today, and he said that he was pretty inspired seeing the lightning talks of Friday. So if you are inspired by chance of all these lightning talks, there's still signups for this afternoon's lightning talks. If Michelle, you could come set up. Next, we have Brian Warner talking about Git lockup.
Hey, everybody. Hi, everybody. Testing, testing. Hi, everybody. Thanks for coming out today. My name's Brian Warner. I work at Mozilla. I'm going to be talking about a commit signing tool that I've been working on called Git Lockup. So we have these wonderful distributed version control systems that we use in a very centralized way. And that's okay. There's some good workflow reasons for doing that. A lot of projects have just a single author. They publish their commits up to a centralized place like GitHub or Bitbucket. And then there are a number of downstream followers that follow along from there. Now, GitHub is great. I love those folks. I don't think they would ever do anything wrong. But it wouldn't be out of you can imagine that somebody could break into their servers, one kind of compromise there, and somebody could go and add a bad commit to one of your projects. Once this little bit of evil gets in there, then your followers are going to go and fetch that. As soon as they run any of that code, their machine might get compromised. Bad stuff happens. Evil propagates. So it's not sufficient that we're simply running Git over SSH. That's great for protecting against network attackers. But the kind of core problem here is that we're depending upon these centralized servers. We're relying upon them to keep all of our code intact. And what we'd really prefer is that we're only relying upon the upstream author for this stuff. This is a good place for cryptography. So what I really want is some kind of tool where every time I commit something, a signature is added to it. We have to define what key is the right key. But I want those commits to be added very easily when those signatures to be added very easily when I commit something. I want those signatures to be sent up to the central server and to follow those commits along. And then I want the followers that are following along at home to be able to verify those commits before they pull them down so that they never run the risk of seeing some evil code. If somebody does manage to break into a GitHub and put a bad commit up there that doesn't have one of these valid signatures, I want the tool to go and reject this before it ever shows up in the downstream side. So Git has some tools for signing commits that are already built in, but I'm not too excited about them. They're based upon GPG. So you have to set up a GPG key for that to work. You have to have the keys of all the people who might be signing it in your keyring to do the downstream side. It doesn't do any sort of protection mechanism. It's really just added to the logs. So you'd have to pull down the code, look at the logs, look for the signature lines, figure out whether each of these keys is the right key or not. And then if there are any problems, you then have to back everything out. So I've been working on a replacement for this kind of workflow in a project I called Git Lockup. It's up on my GitHub repository. The features of it works by having a separate set of keys for every branch. So you might have one set of people that are allowed to publish to your master branch, another one that are allowed to publish to a deployment branch or production branch or different feature branches. And the signatures are attached to commits, but they're not bound, they're not a part of the commit. The GPG built-in Git style actually adds extra text to your commit message in order to make these signatures. These are kept independently in the Git Notes feature, which is this interesting Git feature that lets you add annotations to different commits independently. That also means that you can have multiple signatures for a given commit, which is actually pretty common when you have multiple branches. You might have the same commit be referenced by multiple branches for different purposes. These are using ED 25519 elliptic curve signatures rather than GPG. They're really fast, really small. The keys are super short, which makes things really convenient. The downstream side does a verify before fetch process, so it checks that the signature is valid before it ever lets it touch your local branch, so you don't have to do any kind of backing out of a bad change. And it prevents rollback attacks. It won't let the server pretend that an older version is actually the current one. And it's super easy to configure. So once you've installed Git Lockup, you just run the setup publish side. This is on the upstream author side. That creates a key pair. It configures your post-commit hook to automatically sign all of your local commits. And it makes a couple of files, adds a couple of files to your repository that are going to be used by your followers. So all you have to do is run that tool and then commit and push the stuff. From the signing key is stored directly in your git config file. It's just that one line. And if you want to back that up, that's easy to copy over into some other file. On the downstream side, your followers check out your project and they run the embedded setup lockup script. That then configures their git fetch to only accept signed commits. It's using a public key that's embedded in the source tree, so this gives you trust on first use semantics. Once you've locked up your tree, then no further changes will show up without being signed by the right committer. This includes a pure Python implementation of an N25519 verifier, and uses a kind of funky git remote proxy to get control of the fetch process before merging anything in. So I haven't yet gotten a release on this. I'm hoping with the sprints that I'll be able to get that part done. The GitHub repo is the best place to look for this right now. It's a little bit fiddly. I'm still trying to work out how to get the Git notes feature to push those branches up properly. But check it out. And also I'll put in a plug while you're in the GitHub repo, take a look at my Python versioneer project, which is a tool for automatically managing the underscore version file, getting from Git metadata directly. Thanks very much. Drop me a note if you have any questions.
Thank you, Brian. Okay, so from the Boston Python user group and Boston PyLadies, we have Michelle Fullwood here to talk to us about Arabic and natural language processing.
Okay. Here's that now. Hi, so my name is Michelle. I'm a grad student in linguistics at MIT. Here are a couple of things I like to do. So I enjoy learning languages. It's a hobby, not my day job. I also program for research and for fun. So I'm at this intersection here between language learners and programmers, and it turns out that this intersection is a really dangerous place to be, full of potholes. Let me explain why. So when you start learning a language, you have your shiny new textbook, and you start making flashcards, and you're all excited. And then a few weeks pass, and it starts to get a bit tedious and repetitive, and you think, I could do this better. So I could have interactive exercises instead of just a textbook. I could use spaced repetition with my flashcards. And because you have the power to do this, you give into temptation, and you start coding up your ideas, and this happens. So this is what happened to me with Arabic. And my personal beef was with dictionaries. So just to motivate this, let's say purely hypothetically speaking, we're in a francophone country, and we hear someone say merci beaucoup, and we don't know any French. So you wonder, what's this beaucoup word I keep on hearing? And you type it into to an online dictionary, and you get 0 results. So this was the problem I had with Arabic. So admittedly, Arabic orthography is a lot more regular than French, but it does have its own challenges. For example, it goes right to left. Letters change shape based on context, so these are all the same letter Ain. But more importantly, there are phonemes that are in Arabic that you don't see in English. For example, there's ka, which sounds a bit like a ka to us. There's 2 different kinds of H's, so on and so forth. Even when we have the same sounds, Arabic uses them a little bit differently. So vowel length and gemination are contrastive. For example, hammam isn't the same as hammam, which is unfortunate because you might be asking, where is the pigeon? And Arabic words are also constructed a bit differently from English. So these are 4 words that are related in the mind of an Arabic speaker: kataba, kutiba, maktab, kitab. And you'll notice that none of them share a contiguous sequence of letters. What they do share is these 3 letters, ka, ta, ba. And this is called the root. And here's a linguistic hypothesis about what's going on in Arabic. So you have this skeleton of consonantal and vocalic slots. That's the CVCVC. You have your root. You have your vocalism. The root's up there. The vocalism's in blue. And you associate each consonant to a C slot and each vowel to a V slot. So you smush it all together, you get kutub. What if you have fewer vowels than vocalic slots? No problem. You just associate them to multiple ones. You can do the same thing with consonantal slots. And here's a word that does both. So there's not 3 letters in the root, but we can still form this word. So this is called non-concatenative morphology, and it's pretty insane, but it's a brilliant insane. And after a while, once you start grokking it, you wonder why all languages don't work like this. So now you may be wondering, so this is great, but what's the link to dictionaries? And the answer is that most dictionaries in Arabic are sorted by the root. So in order to look up a word, you have to perform like morphological analysis of the word. So for example, maktab is under kataba, not under m. Okay, so, but you know, this is the 21st century, no one uses paper dictionaries anymore. There's electronic dictionaries out there, but they still need Arabic input, so you need to have installed your Arabic keyboard, you need to know how to type in Arabic, you need to have the exact orthography again. So, so this was my plan. So it was to do fuzzy lookups, and so I want the user to put in a rough transliteration, it would go through a transliterator, give me a set of possible Arabic words it corresponded to, put that through a dictionary and get a list of possible definitions. And you can look through all of these and see which one fits the context. So I was looking around for previous work, and it turns out there's a company called Yamli that does exactly this transliteration, so I'll just show you. And they provide a kind of API, so that's pretty sweet. And for the dictionary, there's a GPL Buckwater Arabic Morphological Analyzer. So that's great. There's two things I didn't need to code, which is almost everything. So I just need to glue them together, which I did in Flask. And I know you all know what Flask looks like. I just want to put some Python up here so I didn't feel like a fraud. So let me just switch over to the actual app. Yeah, so this is it. So you can type hammam, for example, and you don't need to worry about whether I got the H's right, how many M's there were. It gives you both pigeon and bath, for example. Okay? Okay. All right. No, that's fine.
Sorry, I have to cut you off, but that was awesome. Thank you very much. That concludes Lightning Talks for this morning. If you want to sign up for this afternoon, there's sign-up sheets by the registration place. So if we can give another round for our Lightning Talk speakers this morning. Now, for a man who needs no introduction, but I'm going to introduce him anyway because I want to. I have the pleasure of serving on the board, the Python Software Foundation board with Van Limburg. He is also very sympathetic to the PyLadies.